Hey guys, this is another Algebra 2 video. This is Chapter 2, Section 4 for Big Ideas Math, and what we're going to do is use a quadratic function to model a real-life situation. Now, what we need to do is use these formulas that we already have. So they are already something that's on our cheat sheet, but we're going to use them. So pretty much what happens is if you are given a point and the vertex, you are going to use the vertex form formula. If you're given a point in the x-intercepts, you want to use the intercept formula. And if you're given 3 points, you could write and solve a system of 3 equations and 3 variables, but you're not going to. What you're going to do is use the stat calc feature in your calculator, because that's what I've taught you how to do, and that's how I like to do it. So here we go. It says the graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. Write an equation of the parabola. That's it. That's the question. Then it says, the performer lands in a net 90 feet from the cannon. What is the height of the net? That is a second question. So this is a two-part question, and we can solve it. So here we go. It looks like we don't have intercepts, because intercepts would be here at the x-axis. What we have is a vertex. The vertex is 50, 35, vertex, and a point. So we want to use the vertex form, which is a times the quantity, x minus h squared, plus k, and now we plug in what we know. So we know that the vertex is 50, 35. So that would be y equals a times x minus, the h value is 50 squared, plus the k value is 35. Now we want to put our point in there. Could we have put our point in already? Sure, guys, you can if you want, but I just wanted to show my work here. So I'm putting 15 in for y. The a is what I'm trying to find. I'm putting 0 in for x, and I'll just copy down the rest of the problem. And now I need to use my calculator, or maybe I can do it in my head. So I've got 15 equals a times, now negative, so first of all, 0 minus 50 is just negative 50, and negative 50 squared is 2,500, plus 35. What we want to do is subtract the 35 to the other side. So we have negative 20 is 2,500a. So now in our calculator, go ahead and do negative 20 divided by 2,500, and I have that a is equal to negative 0.008. So an equation of this parabola is y equals negative 0.008 times, and now I'm using this equation right here. And that's part of the reason I wrote it separately, because now I know exactly where to write everything. It's the quantity of x minus 50 squared plus 35. So that is one answer. That is the equation. The other question was, what is the height of the net when the performer lands 50 feet from the cannon? No, sorry, 90 feet. So what you do is you plug a 90 in for x. So in your calculator is how I would do this. Just plug it all in. So 90 minus 50, quantity squared. I'm plugging it into my calculator. I pressed the enter key, and I got 22.2. So what is 22.2? That is the feet, and that is the height of the net. Now, does it look like it's 22.2? Look over here. Yes, it really does. That's just a little bit more than 20. So our answers make sense. Okay, it says a meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight, and y is the temperature in degrees Celsius. Write a function f that models the temperature over time. What is the coldest temperature? Well, already we know that the coldest temperature is the vertex. The problem is we don't know what the vertex is yet. And then it says, what is the average rate of change in the temperature over the interval in which the temperature is decreasing, increasing? Compare the rates of change. So we've got lots of questions going on here. The first thing we needed to do is decide which form to use. And if you notice, they have given us the intercepts and they've given us a point. So that's a point and those are the intercepts. So we want to use intercept form. So I'm going to work over here on the side. So that would be y equals a times the quantity x minus p times the quantity x minus q. So y equals a is what I'm looking for. That's x minus 4 and x minus 24 because those are our intercepts. Now we plug our point in. So that's 9.6 equals a. X is 0. Ooh, that's nice. And x again is 0. And now I'm going to just plug that straight in my calculator because I don't think my mind is going to tell me 4 times 24 very quick. Okay, so I've got 9.6 equals a. Negative 4 times negative 24 was 96. And now I divide, so 9.6 divided by 96. And I get that a is equal to 0.1. Okay, so now I'm going to write that up here because that is going to be the function. So f of x is a is 0.1 and then x minus 4 and the x minus 24 go in our parentheses here, and that's done. Now it says, what is the coldest temperature? Guys, we can do this by hand or we can do it in the calculator. Since I'm here and you're here and I've got a calculator, that's how I'm going to do it. But first, let's talk. Remember, it's 4 plus 24 over 2. So 28 over 2 is 14. So I know for sure that this is 14. And does it look like it's 14? Yes, it does. So 14 is what I'm going to plug into my calculator. So I'm doing 0.1 times the quantity 14 minus 4 times the quantity 14 minus 24. Remember, that's the p plus q over 2. That's where I got 14 from. I plugged it in my calculator and I got negative 10. Does that look like negative 10? Yes, it does. So that's fantastic. So the coldest temperature is negative 10 degrees. I'm going to squeeze that answer there. Okay, part B is a little different. Part B is talking about the average rate of change in temperature over the interval. So, and I'm going to need to erase so you can really see this. Rate of change, if you remember, is slope. And when we're talking slope, we are talking lines, not parabolas. So take that 14, negative 10 point, and if you connect it to what you see here, which is the end of the time that they gave us, and if you connect it here to the beginning of the time they gave us, I'm not creating an absolute value function. I know it kind of looks like I am. I'm not. What I'm doing is I'm creating two distinct lines. They're separate lines because one is how fast the temperature changed between 0 hours and, what was it, 14 hours after midnight, and how fast the temperature changed between 14 hours after midnight and whatever that point is, 24 hours after midnight. And so to do rate of change, what you're really doing is rise over run. So let's think about this. The rise would go from -10 to 10. So rise is 20. And then your run is from 14 to 0. So that's 14. Please remember that that's negative. Okay, and then let's reduce this by a 2. So we have -10 over 7 is from 0 to 14 hours after midnight. And then look at our other one. Here is our rise. Our rise was just from 10 to 0, so 10 over. And then our run this time was from 14 to 24. Well, from 14 to 24 is 10, so that's 1. So the slope is 1, 14 to 24 hours after midnight. Okay, so what on earth does that even mean? Well, compare them. One has a slope of 1, and the other one has a slope greater than 1. Because isn't 10 over 7 bigger than 1? 7 goes into 10 once with 3 remaining. So what that means is that the temperature is changing faster right here. The temperature changes faster. And when is the temperature changing faster? Between 0 and 14 hours after midnight. Okay, our last example is when you're given either 3 points or maybe you're given a table of values. Now we have already done this in the calculator with our stat plots for lines and done linear regression, but now we're going to do it for our quadratics. So you're going to go ahead and put this in your calculator. Let me get the camera. Okay. What I did is I went ahead and went to Stat and to Edit, and I've already put that information in my stat. Now I turned my cheat sheet over and I went to Stat, over to Calc. Now you don't want number 4 for linear regression. What do you want? You want quadratic regression, right? Because we're doing quadratics. So that's number 5. Go ahead and store this as normal in the regression equation by pressing vars, going to y vars, and pressing 1, and then 1 again. Go down to calculate and press enter, and that is it right there. That is the quadratic equation. We really didn't do any math ourselves. The calculator did it for us. So now it's our job to put that information in. So it's y equals -11 x squared. The b value is 700, so plus 700x. And then the c value is 2100 plus 2100. Ooh, no, 21,000. Fantastic. Okay, so that is the answer. Now let's see. NASA can create weightless environment by flying the plane in parabolic paths. The table shows the height in feet of the plane t seconds after starting the flight path. After about 20.8 seconds, passengers begin to feel weightlessness. That's pretty cool. It says write and evaluate a function to approximate the height at which this occurs. Okay, so what they want us to do then is plug 20.8 into the function we found. So back to our calculator, it's -11, and then I'm opening parentheses and doing 20.8 squared plus 700 times 20.8 plus 2100,000. Okay, and I got that the height is 30,800, and that's going to round up to 1 feet. Now we could also do this by storing the x value. So going 20.8 and then pressing the STO button and then the X button and enter, but I can do it that way also. All right, I hope you learned something and I hope you're having a good day.